Hey y'all, welcome back. Check it out, here we are, 7.5. Kind of like that. 7.5 is all about us knowing how to do this exponential function stuff. We're just going to be graphing and making this work out for us. So you need to know what an exponential function is. They show up in this form where y is equal to a times b to the x power. A cannot be 0, b has to be greater than 0, but it also cannot be 1. So here's examples of what it could look like for us. So the process for us is going to be just to do the math. All right, let's check it out. I made myself a somewhat cool looking graph here. I'm going to adjust it for ourselves here though. I'm going to make, I'm going to do that. Yeah, there we go. Yeah. I'm making a coordinate plane here so that we can have ourselves things to graph. All right, so our job is to more or less, we're going to make an XY table, a function table, and we're going to plug numbers into our function. Our function is the y equals 4 to the x power. And what we want to do is figure out what this graph is going to look like and use the graph to figure out what 4 to the 1.5 power is, and then be able to name the domain and the range. So what we do when we plug numbers in, we want to plug in our smallest and easiest looking numbers that we know. So we include negatives because weird things happen sometimes when you include negatives. We also want to include the number 0 because sometimes weird things happen when you get a 0. And then some positive numbers as well. So the smallest numbers that include all that stuff is -2, -1, 0, 1, and 2. So what we will do is just plug them into the formula, or into the 4 to the x power. So I will do 4 to the -2 power. I'm just going to type things into my calculator. So I have 4 to the -2 power, and my calculator says that that is 1/16. And then I do 4 to the -1 power. My calculator says that is 1/4. I do 4 to the 0 power. My calculator says 1. 4 to the first power is 4. 4 to the second power is 16. So what I'm going to do now is I see that I have ordered pairs here, and I'm going to graph those things. So if I just make some marks so I can graph that stuff. Well, those are good looking marks. And then I'll make my dots in a black marker here so that we can see a little bit easier. So I'm going to plug in a -2, so I went to the left 2, got a dot at 1/16, which is just barely above the 0 line. Go to -1, which is 1/4, a little bit higher up. At 0, I'm at 1. At 1, I am at 4. 1, 2, 3, 4. Then at 2, I'm going to be way up here at like 16, which is probably off the graph. And what you should be able to see is that my line, as I connect the dots, oh, that was just hideous. Let's try that again. My line, as I connect the dots, there we go, is going to be getting steeper and steeper and steeper and steeper and steeper, and it's never, ever, ever going to touch this 0 line, because at -2, I got to 1/16. If I put a -3, it's going to be 1/64. So we're never going to get to that 0 mark. So that's already going to tell me that my domain and my range are going to be certain things. My domain, because it's going left and right, all directions, it's going to go on forever, left and right, is going to be all real numbers. And here's a quick, easy way to say that. I just put all real numbers. So it's an R with 2 lines, all real numbers. And my range, which is my Y values, is going to be, Y is going to be greater than 0. And because it's never going to get to 0, it's going to be approaching 0. It's never going to reach it. So all the values for Y are going to be greater than 0, because I'm going to follow this line, and it gets up and up and up and up. Over here, it just gets closer and closer and closer to 0, but with never getting to actually being 0. Now, that's my domain and my range. The last step of this problem was to look at your graph and say, where is 1.5? So if I look over here at 1 and then 0.5, I'm somewhere between this 4 and the 16. So maybe I would just even call it halfway there. I'd call it 8. So my guess would be somewhere close to 8. And I can check with my calculator. I'm going to do that just to make sure. 4 to the 1.5 and that it actually is 8. So yay. 4 to the 1.5 is 8, and I would then know the value of what that is just based off of looking at a graph. Now, you can do the same things with this exact problem. You're just going to look at the 0.25 spot. So that here's one hole, so it's going to be somewhere right here-ish, and look up where is your line. That's going to be where you'd say what answer it is. So you're looking for multiple choice A, B, C, or D. We're just above the 1. And we're not, of course, going to be up here at 5, so that one doesn't make sense. So it's one of those 3. And you're going to want to let me know what you think it is. We'll talk about it tomorrow when you guys get back to class. Here's another one for us to work on. I'll make some more graph stuff here. It's really, really a fun thing to do. Check it out. This is like the most exciting part of a teacher's day is making graphs with the computer. I'm sorry, I didn't say that out loud. That was pretty fun, though. So here we are with a different problem. Same process is going to take place. You're going to make an XY table. You're going to plug in those numbers, -2, -1, 0, 1, and 2. And we're going to plug them into this equation and figure out what y is. So I'm literally going to take, for me, I'm going to put 0.25 because 1/4 is 0.25. I'm going to hit that little caret button on my calculator, that little up arrow. It looks like this. So I'm going to find that button on my calculator that tells me I'm going to get into the exponents. And then I'm going to type in the -2 and hit equals. And that's telling me the answer of 16. A -1 is just going to be the same thing here. 0.25 to a -1 is 4. 0 to the 0 power is always 1. 1/4 to the 1 power is always 1/4. And then 1/4 to the second power is going to be 0.0625. Wow, that must be like 1/16. And there we go, 1/16. So what we have here is a different looking graph now. So I'm going to plug these numbers in, make my little check marks so I can graph them. You'll probably want to grab some of my graph paper when you do this problem or this assignment for us today. And what we have is just graphing those things. So I go to the left 2, I'll put these dots in blue. To the left 2 and up 16, so way the heck up there. To the left 1, up 4, 1, 2, 3, 4. To the up 1, then we have a y is 1/4. To the right 1, up 1/4, and then to the right, oh, even further down. So this is almost the exact opposite of how the other graph looked. So my domain and my range are going to be similar things here, except for they're going to be a little bit opposite. My domain is still going to be all real numbers, and my range is still going to be y is greater than 0, because it's all numbers that are going to be bigger than 0 are going to be our y values. And all of my x values are still going to be every single possible real number we have. So that's still going to be our situation for this one, because that's how the graph looks if you look at just the x's or just the y's. And then our next step is just to go ahead and look. Where is 1.5? To the right, 1.5. So it's halfway between that 1/4 and 1/16. I might call it 1/8 would be my guess. That would be my guesstimate here. And I'm going to check it out in my calculator. So I'm going to do 0.25 raised to the -1.5. Oh, I went the wrong direction. Not 1/8. Not 1/8. Let's go backwards. To the left, 1.5. To the left, 1.5. So in between that 4 is probably an 8 again. Oh, yeah. So it is an 8. That's so exciting when we do things like that. So it's about 8. I checked on the calculator. It's actually 8. So we went to the left, 1.5, went up, found our line that we sketched. And that's about at 8 for us. All right, now, folks, that's what this problem's all about. Us being able to plug numbers in for the x value to figure out what y is. You officially can plug in whatever you'd like to plug in, but I would encourage you to plug in numbers like -2, -1, 0, 1, and 2, because it makes sense to have small numbers because they're going to grow very, very quickly since this is exponential functions. Here's our last problem. Your job is to figure out what t is. T is time in years after the car was purchased. If you read it carefully, it's asking you to plug that number in. So you're going to plug it in, see what you get for an answer. And we'll talk about what that specific answer is when you return to class. All right, folks, that's what exponential function is. This is the Burma Nation, and I'm signing off. Holler at me if you have questions.